The state pattern is a behavioral pattern from the Gang of 4 library of design patterns. Its intent is to allow an object to alter its behavior when its internal state changes. The object will appear to change its class. Let's clarify this with an example. Withdrawing or depositing money from or on a bank account. This can result in the bank account changing state from regular to overdrawn or vice versa. If your bank account is defined by a class, bank account, you could add an enumeration property, bank account state, to it. When you withdraw money, the state can potentially go from regular to overdrawn. And when you deposit money, it can potentially go from overdrawn back to regular. Depending on the state of the account, other rules might apply. You might not be able to withdraw money when your account is in overdrawn state. You can solve that with a conditional statement in the withdraw method. That's the switch statement you see on screen. That's easy enough, right? Now imagine an additional state, gold, which you get when your account has a lot of money in it. It allows you to withdraw more money at once. That means that the logic for transitioning becomes a bit more complex, and the conditional statement when withdrawing becomes a bit more complex as well, but it's still manageable. Yet it's not hard to imagine that this can become very complex very fast. Add in a few additional states or business rules, like only allowing you to take out a credit card when your account is in a certain state, changing state of the linked account when you overdraw a credit card, or even an interest rate that changes depending on the bank account state. The way the account behaves depends on the state, and the state can change at runtime. Taking care of all of these business rules and transitions and states in the way just shown will lead to large, difficult to manage conditional statements and state transitions. That's what the state pattern can help with. We'll start with just the two states from the initial example, regular and overdrawn. We still have a bank account class with methods on it to withdraw and deposit money. What we could do is introduce an abstract class that represents the state of our bank account. It declares an interface common to all classes that represent different operational states of the bank account, which includes methods to handle requests that are coming from the bank account, like deposit and withdraw. We name that one bank account state. The bank account class has a bank account state property of this type. For each state, we have concrete implementations, like regular state and overdrawn state. In these implementations, the logic resides to transition from one state to another. So, in the regular state object's withdraw method, we have code that will change the state from regular state to overdrawn state when the balance goes below zero, and vice versa. The more states you have, the more you'll notice this logic will be less conditional and complex than when working with an enumeration. For each state, we have concrete implementations, like regular state and overdrawn state. In these implementations, the logic resides to transfer from one state to another. So, in the regular state object's withdraw method, we have code that will change the state on the bank account from regular state to overdrawn state when the balance goes below zero, and vice versa. The more states you have, the more you will notice this logic will be less conditional and complex than when working with an enumeration, because typically you can't go from each state to all other states. The logic in the withdraw and deposit methods becomes easier as well. For example, there's no conditional statement anymore in the withdraw method on our overdrawn state to check whether we can withdraw money or not. We don't have to check for the state we're in, as the state is represented by the object itself. We already know it. So, when depositing money or withdrawing money via the bank account object, it calls into the underlying deposit and withdraw methods on the bank account state object. And as we just detailed, doing that takes care of state-specific logic and state transitions. By doing so, we vastly diminish complexity. Each state object handles just its own possible transitions and logic. The more different states there are, the more obvious the advantages become. Let's map this to the pattern structure.